Okay, let's talk about similarity, which is a really important concept in geometry. Let's first remind ourselves of what congruent means, because it's kind of similar to similarity. So, two figures are congruent if you can translate, rotate, and/or reflect one shape to get the other. The angle measures and the side lengths are the same for the two shapes, okay? So basically what you're doing is a certain set of transformations here. Now, similarity is a little bit different. Similarity has when two figures are similar, if you can translate, rotate, reflect, and/or dilate. So we've added in dilate to the list here, and you get from one shape to get to the other. So the angle measures are going to be the same, but the side lengths may be different if you use dilation there. Okay? So let's look at a few examples. We'll go ahead and put some shapes here on the coordinate plane. We've got P, Q, and R. So let's first talk about shapes P and Q. So if you take P, you can rotate it to get this around the origin to get this shape here that I've now put in there. And then you can reflect it to get Q. So if we look at that, we can rotate and reflect. That means that the two shapes are similar. It also means that they're congruent. So let's go ahead and write that over here. Figure P and figure Q are congruent because you're only doing rotation and reflection. They also happen to be similar. Okay, now let's look at P and R. So what we did here is we take P and we go ahead and translate it over and down, and then we dilate it to get R. Okay, do you see how we take P to this shape and then dilate it to this shape? So now we're using dilation, which means those two shapes are similar. So we'll go ahead and write that because you can translate and dilate, but they are not congruent because we've used dilation. So that's the difference between similarity and congruence. Remember, congruence, like P and Q, those are going to have the same side lengths and the same angles. Similar, like P and R, are going to have the same angle measures, but not necessarily the same side lengths. Now here's an interesting question. What can you say about Q and R? Well, it looks like you could probably rotate Q and reflect it to get back to P, and then go ahead and do the same translation and dilation. So eventually you could get from Q to R. So they're also similar, but because you need a dilation, they're not congruent.